A very interesting and a very important example to understand quadratic approximation is the example of the trigonometric function cos x. Now cos x, we did find out the linear approximation for cos x around 0. Cos 0 is 1 and the linear approximation of the function cos x around 0 actually came out to be as 1. So what we meant to say that the function is almost like 1 around 0. Okay, a constant 1. So here is the working for it. We figured out how to find out the approximation we required f dash. So our working was essentially fx is approximately same as f0 plus f dash 0x, right? Now, when we're looking at quadratic approximation, we will just add on something to it. What will that be? That will be an f double dash 0 by 2 into x square. Now, this first portion, this gave us the value 1. This gave us the value 1, right? This gave us the value 1. And that was because the f dash at 0 came out to be as 0. Now what we require is to find out f double dash x. Now what is f double dash x? What was f dash x? F dash x was minus sine x. So this will equal to d by dx of minus sine x, okay, which equals to minus cos x, okay, and cos 0 is 1, so hence this becomes minus 1 at x equals to 0, okay. So my quadratic approximation essentially will be 1 minus 1 by 2x square. So what does this tell me? What does this tell me? This tells me that if I look at the quadratic approximation around 0, the shape of the function will be such that it will be less than 1 around 0. Okay, it will be less than 1 around 0 for every value of x. And that's what is happening out here. That's what is happening out here. We can easily see when we look at the quadratic approximation, the curve is below 1. So for every x around 0, the functional value is less than 1 because the approximation is 1 minus x square by 2. Okay, so little less than 1 everywhere, and that is what is the shape of this function telling us. This is what is the quadratic approximation telling us. It tells us that the curve is below 1 and it is in a parabolic shape.